Okay, so let's go ahead and take a look at this lesson. So this lesson is characteristics of a quadratic function. And essentially, if I told you before, like if you have a vertex, I should just do some highlighting. If you have a vertex, you have a minimum value if a is less or greater than 0, and you have a maximum if a is less than 0. A concave upward function is a function that looks like this, where it's opening upwards, meaning it holds water, and a concave down function is something that's like a frowny face. It doesn't hold water. Domain is typically the values of x, or we call it the values of the independent variable. Range is the values of the dependent variable, or the values of y. X-intercepts are called a root or a 0, and they are found when I take an equation and I set it equal to 0. End behavior is what happens when x approaches infinity. So when x gets very, very large positive numbers or very, very small negative numbers, we talk about end behavior. And the leading coefficient, which is the value of a, if that is positive, then both go towards positive infinity. The function is concave up, and I do have a maximum value. Okay. And then if I'm negative, so my a value is negative, then I'm going towards negative infinity both ways. I'm concave down, and I have a... Oh, these are backwards. These are backwards. It's a minimum here for concave up. I cannot spell either. That's great. There's a typo. I'll have to let Mrs. Roach know. There's a minimum here, and then this is not true. And it's a maximum here. So the function opens upwards or opens downward. Okay? So that's kind of what the picture looks like. Okay, so now let's look at some examples. Okay? So here I want to look at, okay, so the sign of the leading coefficient. So the leading coefficient is 1. So then a is greater than 0. So this is a positive leading coefficient. So the end behavior, so as x approaches infinity, then f of x approaches infinity, larger and larger values. As x, I can't even think right now. As x approaches, oh my lord, negative infinity, then f of x approaches positive infinity. Because a is positive, it is concave up. And the x-intercepts are when I set this equal to 0. So x squared plus 2x minus 3. So this is 2 on the top, negative 3 on the bottom. So, no, just kidding. Oh my gosh. 3 and negative 1. So this is 0 is equal to x plus 3 and x minus 1. So that x is equal to negative 3 and 1 are my x-intercepts. So my x-intercepts have 0 y values. So it is negative 3 comma 0 and 1 comma 0. Okay, your y-intercept is when x is equal to 0, so y is equal to 0 squared plus 2 times 0 minus 3, so y is equal to negative 3. So my y-intercept is a coordinate point also, just like the x-intercept, which is negative, oops, just kidding. Oh man, it's been a long day. My y-intercept is 0 comma negative 3. And then my symmetric point we would do by graphing. So let's graph my vertex. I have to find my vertex first. Negative b over 2a, so negative 2 over 2 times 1, so that's negative 2 over 2, which is negative 1. So y is equal to negative 1 squared plus 2 times negative 1 minus 3. So that's 1 minus 2 minus 3. So then that gives me negative 4. So my vertex is negative 1 comma negative 4. Okay. It is a positive, so this is a minimum. And then we'll wait for domain and range until I actually graph this. So negative 1, negative 4. My y-intercept is at negative 3, so my symmetric point that I did not answer. It's always easier to do your symmetric point after you've graphed. So that gives me negative 2 comma negative 3. And then I connect the dots, which you could graph your x-intercepts. I'm not super concerned about you doing that though. Okay, so my domain and my range. So my domain are all the values of x, so that's all real numbers. And then my range though, I don't go any lower than my vertex of negative 4. So my range is from negative 4 less than or equal to, I should just say y is greater than or equal to negative 4. That'll just be the easiest. We'll worry about other notation later. Okay. I'm going to skip 2. I'm going to go to 3. So, all right. So our leading coefficient for this one, so my a is a negative 2. So then my leading coefficient is negative because a is less than 0. My end behavior, because a is less than 0, then as x approaches infinity, then we could use f of x, but I could just use y approaches negative infinity. And then as x approaches negative infinity, y also approaches negative infinity. So then this is a concave down situation. The x-intercepts, I would be setting my equation equal to 0. No, minus 1. So now when I go to factor, right, 6 and positive 2, there's no numbers that actually work out for this. So the only thing that I can do is to use the quadratic formula, unless you really want to complete the square, but then I got to use the quadratic formula. So x is equal to negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So x is equal to negative 6 plus or minus the square root 36 minus 8 all over negative 4. So then I get x is equal to negative 6 plus or minus 36 minus 8 is 28 over negative 4. So then 28 breaks down into 2 and 14, 2 and 7. So x is equal to negative 6 plus or minus root 4 root 7 all over negative 4. So x is equal to negative 6 plus or minus 2 root 7 over negative 4. Everybody is divisible by 2, so this is x is equal to negative 6 over negative 4 plus or minus 2 over negative 4 root 7. So this is x is equal to 3 over 2 plus or minus this 1/2. And, because it's a negative here, it's either going to be plus or minus still. So it doesn't make any difference that I put the negative down there or not. Really, the negative actually affects this first term here more than anything. Okay. And then my x-intercepts, so nothing really simplifies. So really your x-intercepts are 3/2 plus 1/2 root 7, comma 0. And then 3/2 minus 1/2 root 7, comma 0. Okay. So I'll erase the x because that doesn't work. Okay, because it doesn't factor. So my y-intercept is y is equal to -2 times 0 squared plus 6 times 0 minus 1. So that equals -1. So my y-intercept is 0, comma -1. My vertex is -b over 2a. So that's -6 over 2 times -2. So then that gives me -6 over -4. So that gives me a positive 3/2. Okay. And then I have to find my y value. So y is equal to -2 times 3/2 squared plus 6 times 3/2 and then minus 1. So y is equal to -2, 9 over 4 plus 18 over 2 minus 1. So y is equal to -9 over 2 plus 18 over 2 minus 1. So this gives me positive 9 over 2 minus 1. So 9 over 2 minus 2 over 2, which equals 7 over 2. So a really long process for my vertex to be 3/2, comma 7/2, which requires effort. Let's see, so 3/2. So 1.5, comma 7.5, or 7/2 is 3.5. So here's my vertex here. My y-intercept is at -1. So that makes my symmetric point at 3. At 3, comma -1. Okay, and then I play connect the dots, and then that is my parabola. Okay. My maximum or minimum, it is a maximum because it's opening downward. And my domain is all real numbers. And my range has to be y is less than or equal to whatever my vertex is. So that's 7/2. Okay. And that is it for this lesson. I don't think I'm doing anything. Yep, that's it for this lesson.